All right, hello everybody. Welcome to the parallel session on resilience to coastal natural hazards. Hoping everyone's enjoying the festive activities of this week. Today we have an esteemed group of panelists to dive in and unpack some of the elements around resilience to coastal natural hazards. The way we're going to run the session is that I will start off with a setting of the stage, and then we will move on to each of the presenters. And then after that, we will have a question and answer segment. So everybody, feel free to present your questions or share your questions in the chat, and we will try to get to as much as possible. My name is Andrew Kruczkiewicz, and I'll be the moderator for today. I'm going to start off with showing a few slides. Let's see if this will work. All right. Okay, could everyone see the screen? I'm hoping so. If I could get just all right, I'll take that as a yes. So yes, welcome everybody. So setting up the stage, let's see if this clicks through. There we go. So here is our set of speakers today. We have Obassi Ettu from Nigeria, Marco Tedesco joining from Columbia University in New York, Jose Luiz Zêzere joining us from Portugal, and Lafayette Dantas joining us from Brazil. So each of the panelists will have an opportunity to expand, of course, more about their role and then share their presentation. But we'll start with this initial setting of the stage by myself, Andrew Kruczkiewicz. So I'm based also at Columbia University in New York at an International Research Institute for Climate and Society. Yeah, the agenda here, as we went over briefly before, setting of the stage just for a few moments. Then we will move on to Obassi Ettu, Lafayette Dantas, Marco Tedesco, Jose Luiz Zêzere, and then we have opportunities for questions and next steps. So, setting of the stage. In being inspired by the discussions happening this week and the motivation of the summit, I've been thinking about some of the key elements that have been coming together in my mind and also from different discussions that I'm having around this event. And something that is emerging as common themes is this idea of around strategic cooperation and this idea of the intersection of science, policy, and practice. And reviewing the presentations of our speakers and the content that they're going to share and the ideas and the questions that they're going to share with all of us, what is emerging here is an opportunity to have a deeper discussion about what that means, the intersection of science, policy, and practice related specifically to coastal resilience. And there's different dynamics happening there. I mean, we need to prioritize science, of course, but we need to understand how that influences policy. And this needs to be done in a way where action can be taken and prioritization can be justified. So I listed some thoughts here where we're going to touch on today. The intersection of geophysical and non-geophysical factors. How do we balance this? What are the tensions present there? Where do they fit in to this kind of three-part framing of science, policy, and practice? Partnerships and strategic cooperation. I'm going to share an example from my work in the next couple slides about this because I think this is important. Cooperations and collaborations don't happen by accident, as we all know. So how do we think about incentivizing these partnerships, specifically on the community side? I think it's clear that we need to elevate community voices and opinions in our planning process. But how do we know what sufficient means? Is that even the right word to present here? And then prioritizing is more difficult in my opinion, and deprioritizing. So I encourage the participants here to think about that, prioritizing and deprioritizing different interventions on different scales. What does that mean? What is the threshold of, let's say, good science, accurate science? If we're trying to say one area or one community or one sector gets prioritized for different types of interventions, not only now, but moving forward using climate information, geophysical information that is increasingly uncertain as we move forward in time. So these thoughts are yes, coming out of the discussions and the presentations, and I thought it would be useful to share an example of some of the work my team is doing at this intersection. And the example that I want to share is maybe something that hasn't quite been discussed this week, or may not initially seem relevant to the idea of coastal resilience. So this picture here, I'm not sure if anybody recognizes it, but this is a picture of Camp 10 in Bangladesh. In Cox's Bazar, Bangladesh, this is a picture of the Rohingya refugee camp. And my team was supporting some of the UN actors there, the Inter-Sector Coordination Group, International Organization of Migration, UNHCR, and UNDP, here in the camp to better understand the risks of different hazards and how to prioritize. I mean, about 2 years ago, 700,000 plus Rohingya people fled Myanmar and settled in this part of Bangladesh. And we could see here, there's no trees left in this area. There are many camps, many makeshift camps. And again, what is the relationship to coastal here? Well, it is on the coast. That district, Cox's Bazar, is on the coast, and we have different activities happening. We have different sectors operating, different types of livelihoods, not only coastal based, but also related to the activities ongoing to manage a very large refugee camp. The question that my team was tasked to support were the following. Where can floods occur? What types of floods at what time? Seasonality of different types of floods. And then where do we prioritize limited resources? In the context of refugee camp operations and management, this is a relatively well-funded operation. Still, there are limited resources. And still, the questions arise about prioritization and deprioritization. And I'm thankful that our speakers will touch on the idea of vulnerability and exposure, because that was one of the primary drivers here. This is a situation where everybody is most vulnerable. If we're talking about the most vulnerable people in the world, we have 700,000 people here that are the most vulnerable. Where do you prioritize when everybody is the most vulnerable? If you need to go someplace first to intervene relative to flood risk, how do you justify deprioritizing people? It's a really difficult question and something that we struggled with. Just for a bit more of let's say, geographic placement here, this is Cox's Bazar district in white. On the left side of this map, we see the Bay of Bengal. So I realize this is not Atlantic related, but it is coastal related. So that's why I'm sharing it here. And we can see some features here. We see in the center of the map, Shamlapur. We have 7,000 plus refugees living right on the coast. So this is a refugee camp that is directly on the coast, impacted by storm surge and coastal flooding, and also impacted from other hazards such as landslides. Up to the north, we see that red polygon. That's the Kutupalong mega camp. So it's not directly on the coast, but still impacted by sub-hazard from tropical cyclones, for example, extremely heavy rainfall and landslides. Then down to the south, to the bottom right of the map, we see some other camps down there. Leda camp, Nayapara camp, upwards of 30,000 plus refugees living right on the river there, separating Myanmar and Bangladesh. So this is a different set of hazards with different seasonality, different impact profiles. So in this area where we have upwards of 1 million refugees, we have different types of coastal hazards impacting populations at different times. Further, there's different types of economic activity, not only happening within the camp, kind of under the radar, but also in the host communities in this region. So I wanted to show this map to let's say, align with this concept of the blue economy. Like, what is the blue economy? What does the blue economy look like in different parts of the world? Even in areas where we have the most vulnerable situations, complex scenarios, such as what we have in Bangladesh here, what is happening? And I selected this picture. These are pictures we took from our time there. On the left, this is a picture from Shamlapur camp. These are the fishing boats that the host community are using and have been using for many years. It's part of their culture. And it's part of the traditional fishing practices that are ongoing with and without the presence of the refugee camp. In the bottom right, this is a picture from the Leda, just outside of the Leda Narapara camp. This is a brick factory that is right in the coastal floodplain of the river. So there is major economic activity happening in these areas. And in the top, even within the refugee camp, we see this young person here working with a job and moving a bag from one place to another. So the story here is things are happening, even in contexts where the idea behind like management of a refugee camp may not necessarily be to think about the granularity of the different types of economic activity and the livelihoods of the host communities here. But this was something that was of most importance when we're trying to better understand disaster risk reduction and resilience opportunities, not only to one type of flood, but to different types of floods throughout the area of interest from the interagency or the intersector coordination group. So I will leave it here because the last connection to coastal resilience is this location here. This is one of the Char areas, which is a piece of land in the Bay of Bengal that has been selected as a potential area where some of the refugees may move to. And I'm going to leave it off here before we transition into the next presentation, because I think, to me, this picture is telling where we have to make tough decisions. We have to prioritize. And in areas where no decision is going to be kind of elevated into a position of being the best or the most appropriate, how do we justify taking action or justify inaction? How do we indicate who is the most vulnerable, and how do we prioritize based on science-driven policy, and then based on practice and implementation of these actions in a way that will reduce risk to, again, the most vulnerable populations in the area of interest. So I will hand it off to our panelists. And I hope they could maintain the thread of how do we do that? What questions do we need to ask? What are the opportunities to use science to develop good policy in this idea to promote resilience? Resilience for who, and resilience to what? So I'll pass it off to our speakers, and I will ask them to share their screen. I will stop sharing my screen now. And then I will pass it over to Obassi Ettu. Please introduce yourself and what organizations you are representing, and then move on to the presentation. Thank you.
I think Obassi is muted, Andy.
Hello? Hello?
Hi, Obassi. Yes, we can hear you.
Can you hear me?
Yes.
Yeah. Okay, thank you. I said my name is Obassi Ettu, and I work with the Raw Materials Research and Development Council in Abuja, Nigeria. While we wait to get to your questions, but I want to share slides on overview of the Nigerian flood scenario. And my presentation will have the outline of looking at what flood is all about, then look at some facts about flood, then look at the Nigerian flood itself and the causative factors, and then evaluate the 2018-2019 flood situation. And then our joint, what we call our reference point in flood, was in 2012. You try to see what happened then. And then we can look at strategies that are necessary to mitigate this. We are all familiar. Okay, yeah, approved. These are pictures we are familiar with. Andrew has just shared some of them. This is our own case of the Nigerian picture scenario. Sorry. Okay. This is a picture of the Nigerian case scenario, actually. Some familiar pictures. You can see workers, you can see people either inside the river or broken parts of the infrastructure and cars that are submerged. Thank you. Next. Okay, in introduction, I will just define flood as an overflow of water body that submerges land and covers anything from inches up to meters. We can see that they are commonly spread natural disasters everywhere in the world. The kinds of floods we experience are things like river floods, coastal floods, storm surge, inland flooding, and flash floods. The common factors are heavy downpours of rain, reservoir failures and infrastructure that retain water, issues like volcanoes, melting of snow, iceberg, moderate. This is not conversant with Nigeria, the iceberg melting and glaciers, but moderate to severe wind that come from cyclones and unusual high tides and tsunamis. These are possible causative factors of flood. I'm interested in looking at tropical cyclone because they carry with them what I might call the three destructive factors. That is the wind, the rainfall, and the storm surge. These are intense cyclic winds that originate from the ocean and characterized by low atmospheric pressure, high winds, and heavy rainfall. When this heavy rainfall comes, that is when we begin to see some flood, especially mostly in the coastal areas and when riverbank overflow. Here are the images of a cyclone and then the satellite image showing 5 tropical cyclones churning themselves up from the Atlantic. And when this happens, people along the coast begins to get ready. Look at the global overview. It is said that by 2050, the people living in flood-prone areas is estimated at 1.3 billion, which is about 15% of the global population and represent an increase of about 0.3 billion from 2017. Flooding is an incident, is a disaster that accounts for 40% of total disasters globally. And we have heard from institutions with repute that within July 2019 to August 2019, the Global Disaster Alert Coordinating System, that is GDAC, reported incidences of 12 countries worldwide with flood, just within that period. And between August to September in 2019, GDAC also recorded a total of 15 active and spent tropical cyclones that actually caused this around the Pacific. Africa is seriously worse hit by the flood incident. And then in 2019, in 5 months from April 19 to September, we have seen about how many countries, over 10 of them affected by this, including Sudan, Kenya, Mozambique, Uganda, Mauritania, and Morocco. East Africa is also affected, Kenya, Somalia, but West Africa is not left by. In East Africa, we are having over 70,000 people affected by flood. A research also showed that global warming is responsible for what is happening in the ocean that will come to affect us as coastal flood or other forms of flood. But be it as it may, the pictures are not looking bright if we don't do the right thing. If we continue to allow gas emissions and not reduce them, over 30 million people could face a once-a-year flooding by 2050. Then here is the news, actually, which I got from floodlist.com. When you listen to the news, it's not interesting. Sudan, 625 people affected. Ghana, deadly flood. Chad, 300,000. Sudan, 166 house damage. That is the news. The news is not a cheering one. Ethiopia, 144. And that goes on, that goes on. The news goes on. Just this clip to show you, and then a picture by the side to tell you what is happening. Flood in Africa is a very severe disaster, and it comes heavily seasonally, especially during the rainy season. Nigeria is not left out. Incidentally, Nigeria finds itself in geopolitical situations that also has flood activities. And that is the news from 2017 to 2018. It's all about news of flood and the number of people killed, the properties lost, and things like that. It's not a cheering news at all. We are in it now. We are in it this period, and you can see some of the flooding between 2019 and 2020. These are animals that are used to carry load. They are now swimming there in the river, and people looking for an upland where they can settle. The vehicles are not left out. The houses are brought down. especially those in the waterways. The flood has risk factors and dangers, there is no doubt, which is brought about by rain, river flow, tidal surge, topography, flood control, and others. Flood effects are very enormous. Flooding, they reduce crop harvest, they destroy food, they destroy road, they destroy facilities, they reduce labor, and even increase the cost of doing things within such period. Looking at the Nigerian flood system, we have recorded a lot of mortality, physical injuries, widespread infection by vector-borne diseases and social disorder, homelessness, and food security. These are all dangers or situations that can be brought about by flood. A record of the World Resource Institute marks Nigeria as 10 on the list of the top countries with greatest flood. That was in 2016. But let's look at the map itself. The white contour you are seeing around the map is the map of Nigeria. You can see there's a highland somewhere in the middle, but two major rivers are very evident, the River Niger and the River Benue. River Niger and River Benue are the main causative factors with their tributaries of flood in Nigeria, especially during the rainy season. And on my right, which possibly could be your left, that is the ecological zones of Nigeria, from the Sahel savanna to the normal Guinea savanna, and then to the equatorial rainforest down south towards the coastal area. The mangroves are also being destroyed. River Benue, the major rivers of the country, I have told you, River Benue and River Niger. You can see that River Niger, there are 5 river systems that cause flood in Nigeria. You have the Niger River, the Benue River, the Chad River, the Imo in the southeast, and then the Littoral Province in the west, where you have rivers from Osun, Ogun, and the rest. The map on my right tells you what the river system in Nigeria looks. It's a web of a system. Now, this web of a system is categorized into 8 hydrological settings. Hydrological setting 1 you can see in the north, and hydrological setting 3, and then the middle area you can see 2 and 3, and that. Those are all the hydrological areas and the drainage area which they affect. And then we have done a bit of description of what those areas are, as you can see in the on the table. The causes of flood in Nigeria, basically for this time, extreme rainfalls. The rainfalls are enormous. And when they fill the river, we begin to see soil moisture increasing, and prevailing weather conditions presumed to be associated with climate change. And then dams, which cannot hold water, sometimes get broken. And then the topography of the country is also not healthy. Urban flooding is mainly caused by flash floods, actually. The use of river channels, which are usually blocked, also cause that. We have a situation where we are still letting people know not to put waste along the along the river course, because that blocks them and causes flooding. You can see some pictorial views. These are, some of them are deadly anywhere. The types of flood we have already defined before: the river flood, the flash flood, the coastal flood, and the pluvial rainfall flood, which comes from rain. One is the overflow of the river, the other one is the flash from steeper area, and the coastal one when the tidal levels increase, and then the raining one. Incidences of flood of Nigeria abound, but I try to categorize them year after year, like the flood that happened in Kano, Kebbi, Sokoto, Jigawa was in 2010. Then in 2011, there was little flood, but what we can see is that there were heavy rainfalls actually, and a lot of properties and these things were damaged. In 2012 is Nigeria's reference point on floods, because that is when we had the highest flood. And then we saw it caused a lot of destruction. It is said that about 30 of the 36 states in Nigeria were flooded, and approximately 10 million people were affected, and 360 killed and displaced, while 21 were displaced. So we have some records, at least, of what 2012 caused, and we are using that as a measuring meter for other flood years. 2014 was less than 2012, but was also this too. 2015 affected states like Anambra, Adamawa, Kano, Kebbi, and Sokoto. And in September, these people had about 11 people died in some of these states, and over 100,000 people displaced. In 2016, we had a similar scenario. The same thing with 2017. But what is more interesting is to show that Nigerian River, which forms possibly a confluence around Alokoja, if you look at the map and the one I circled in red, you could see how the rivers increase within this period from a small distance. And when the flows come, the tributary, that is the confluence, increases and the whole area becomes flooded. That is located at the center of Nigeria. Flood scenarios in Nigeria, I have tried to do something to put them according to state, the date they happen, and the hazard they cause, the impact they cause, and what is the source of my data. I have tried to do that in all the flows that have happened between June to August 1921 or 2019. Then evaluating the floods, Geological Agency, the Nigerian Hydrological Survey is the agency that has the mandate for flood and drought in Nigeria. And therefore, they have done some bit of work to bring out data to show what we suffered during 2020. I've looked at the years again, which we have discussed, but what is important is this picture. The threshold you see that gets up to 13, that is the 2012 season, which we are using as a measure. You can see that in 2019, it was less, 2018, it was less. But you could see which thresholds are normal, where we have the warning alert and where we have the red alert. So in 2019, we recorded red alert. In 2018, 2019, we recorded, and in 2012, we had the highest. You could see that. But what is causing this? Just look at the outlook of areas that are vulnerable. Predictions for 2020. And you can see in red on the map on your right, you can see in red those areas that are close. Some of them are already experiencing, like Kano, Sokoto, Jigawa, in the northeast and northwest, they are already, but it's not central, where the confluence of the river is very prone, and then the coastal ones. The strategies we have tried to look at that might help us manage our flood is the preparedness. This flood management should be looked at in terms of grouping them into phases. If you can take care of the first phase, preparedness of the phase, which requires strategic awareness, you can look at the activities that you are supposed to do. And then in prevention is the second phase, and then response and mitigation phase. These are phases that need to be looked at when dealing with flood. But other strategies might come in, like deployment of automated monitoring systems. There are places we have selected, we know, are prone very much to flood, and we have selected them to be dealt with deployment of automated system. State-of-the-art grounds and space stations to monitor, and then we're developing mobile application. Then data processing. We need to put the data together to be able to tell us what is going to happen next. Quick and efficient response. Use of small propeller aircraft, drones, and all the rest. And then collaboration. I have said capacity building and collaboration are key. We need to train people and develop and have relationship with others. This is the data used. The data used is coming from Geological Survey, the National Hydrological Center, and things. If you look at the map on your right, where you have the red map, that is where the station, the hydrological station are located to measure and meter situations so that they can give information to the people. I think looking at that, I can say thank you for your attention. And thank you because we are still celebrating our 60th anniversary. Happy independence to you, Andrew, and the rest. Thank you.
Thank you very much, Obassi, for the presentation and the description of the different types of floods, the impact, and also some of the priorities that your organization is discussing. And we will, I'm looking at the clock now. I do not think we have time for any questions now, but I'm sure we'll have questions at the end. So if anyone has any questions, well, Obassi, please just hold them and place them in the chat for later.
Okay.
Yes. So now we will move on. The next speaker will be Lafayette Dantas da Luz. Over to you.
Okay. Just a second, please. I'm here. Espero que estejam visualizando. Ok. Bom dia a todos. Eu saúdo os participantes desse evento, saúdo, parabenizo seus organizadores e agradeço o convite e a oportunidade de estar aqui. Para iniciar minha fala, só faço pequena pontuação de que, como tudo nessa vida, temos vários lados, né? Assim como essas duas fotos das inundações, que expressam, né, lados diversos na sua ocorrência. Bom, sabendo que a sociedade, as civilizações humanas se estabeleceram, né, a partir do posicionamento junto de sistemas fluviais e mananciais hídricos, né, e normalmente se beneficiando de que as cheias traziam um aspecto de fertilização de suas margens, portanto, beneficiando aquelas populações de ali se estabelecer, né? Entretanto, as ocupações dos territórios se deram frequentemente de uma forma potencialmente arriscada, certamente não muito perceptível naquele momento em que elas foram o seu início. Como exemplo, trago aqui o caso emblemático da cidade do México, mas outros exemplos similares poderiam ser possíveis. Essa cidade do México, né, se estabeleceu um local circundado por água, né, áreas úmidas, e com o tempo essa paisagem foi radicalmente transformada com a urbanização e aterramento para o que temos hoje, que é impossível se pensar, um caso como este, não haver problemas com relação a acomodar as águas com a ocupação urbana. Bom, as inundações no Brasil, elas têm como causa essencial as chuvas intensas e, claro, que na costa, o efeito das marés altas, né? E o Brasil, com sua extensão territorial, apresenta grande variabilidade nos padrões hidrológicos observados nos rios, em função de evidentes diferenças climáticas e geomorfológicas do território. No entanto, as inundações, cada qual com suas características particulares, em termos de frequência, magnitude, sazonalidade, entre outras, ocorrem em toda parte, enfim. Eu trago muito brevemente dados, bem menos do que o Dr. Obassi fez, observando um rápido estudo aqui que mostra um panorama nacional, né, com base em séries históricas de vazões máximas anuais, onde tem se observado a não estacionalidade desses eventos de cheias, inundações, e isso pode ser ainda potencializado por mudanças climáticas, né? Observa-se em azul aí, né, na tendência ao crescimento das cheias, um aumento das inundações em regiões ao norte, sul e parte do sudeste do país. Por outro lado, existe uma tendência de redução das máximas cheias na região nordeste e boa parte do sudeste também. As regiões mais úmidas do país, né, tendem a ter cheias mais frequentes, mais intensas, enquanto nas regiões mais secas a tendência é de uma certa redução dessas cheias em frequência e magnitude. É isso que os dados têm mostrado. Isso é corroborado, né, com resultados de muitos modelos de circulação global da atmosfera. Eu venho destacar aqui uma importância fundamental das cheias e inundações no aspecto, num dos lados da moeda, né, no provimento de serviços ecossistêmicos, atuando como um gatilho para muitos processos físicos, químicos, biológicos, né, e sendo que a biodiversidade, né, se beneficia com essa regulação provida pelos eventos de inundações no longo prazo, né? Então, a alternância de épocas úmidas e secas, então de cheias e momentos de seca nos rios, proporciona fases aquáticas e terrestres nos ecótonos ripários, né? Quando as várzeas e as planícies de inundação, elas atuam na transformação e transporte de nutrientes, na morte e renascimento das vegetações aquáticas ribeirinhas, na reprodução dos peixes e outros tantos organismos, né, dentre outros processos, que eu vou me abster de entrar em detalhes, né? São importantes tópicos para a pesquisa, claro. Essa importância, né, das inundações é bem consolidada no conceito do pulso de cheias, apresentado por Dr. Wolfgang Young e desenvolvido com bastante foco na região amazônica, que enfatiza a conexão e conectividade daqueles ambientes, e isso aí também é aplicável em outros rios, né? E são impulsionadas essa conectividade e essa conexão pelas cheias, provendo conexão entre o canal fluvial e as planícies de inundação, dos fluxos de energia e alimento e também renovação das várias em termos biogeoquímicos e geomorfológicos, né? Bom, outro lado dessa moeda, né, está na associação das inundações a desastres. Enfim, as inundações afetam áreas, evidentemente, aquelas que são ocupadas, né, por urbanização ou outras atividades econômicas humanas, e mundo afora nós temos as inundações sendo apontadas como o mais frequente dos desastres naturais, correspondendo a 43% destes, afetando 55% das pessoas que sofrem com algum tipo de desastre natural. E ainda levando a perdas econômicas, numa das quantificações, né, na ordem de 104 bilhões de dólares por ano. O Dr. Obassi trouxe muito bem uma série de exemplos a respeito disso, né? Em países subdesenvolvidos, às vezes chamados de emergentes, como no caso do Brasil, situa-se como um segundo maior em termos de potencial para danos e perdas decorrentes de inundações, né? Nas décadas dos anos entre 1991 e 2012, 71% das mortes e 32% das pessoas afetadas por desastres relacionaram-se ao caso de inundações ou enxurradas, as flash floods. Bom, existe uma série de interações em cadeia e o modo de produção e de vida da nossa sociedade reúne elementos e eventos, né, naturais e condições climáticas com ações antrópicas, a exemplo do desmatamento e mau uso dos solos, com a erosão consequente, né, a erosão e assoreamento dos rios, também resultando esse procedimento, né, na depressão e da disponibilidade hídrica, bem como, por outro lado, no aumento dos vazões de pico e das inundações, né? Certamente, as ocupações das áreas inundáveis se configuram numa exposição, né, ao evento das cheias nos rios. E, geralmente, essas áreas são ocupadas muitas vezes por populações mais vulneráveis, né? E, além de que eliminam a proteção aos cursos d'água, né, em função da retirada das matas ripárias. Então, a ocupação até a margem. Se some a isso a questão dos resíduos sólidos e líquidos, né, e contaminantes que acabam por chegar e se acumular nos sistemas fluviais. E, em decorrência de uma ocupação descontrolada e da percepção, né, da população e dos governantes, inclusive, das inundações como desastres somente, é ainda generalizada uma prática de canalização dos rios, né? Existem outras práticas, como a barragem de contenção de cheias, enfim, não vou trazer esse exemplo, estou enfatizando aí com as fotos, um caso que infelizmente eu exemplifico aqui com uma foto de um dos rios da minha cidade, de Salvador, né? Onde essa prática é corrente. Que é um exemplo também de recursos financeiros utilizados equivocadamente, aquela questão da priorização que o Dr. Andrew colocou no início, e efetivamente esse investimento não afeta aquilo a que se propõe, que é o caso das inundações, né? E ainda agrava os problemas ao conduzir ainda mais eficientemente os esgotos sanitários e resíduos sólidos, que deveriam ser objeto, na verdade, de aplicação daqueles recursos financeiros prioritariamente, né? Isso se dá nessa cidade de Salvador, aqui uma visão geral, né, que se situa numa posição peninsular, sujeito ao agravamento de inundações em decorrência da eventual elevação do nível do mar. Então, aqui no caso, nós temos a incidência de chuvas como principal elemento causador de inundações, mas, basicamente, a elevação dos níveis do mar viria a se somar a um causador, né, de problemas. Todas essas questões aqui apontadas, né, na verdade, devem ser pensadas e tratadas num contexto de histórica e profunda desigualdade social que é no nosso país, o que agrava quaisquer problemas diante do estado de pobreza e vulnerabilidade daquelas populações que são mais afetadas pelas inundações, quer dizer, a população pobre, e torna qualquer solução ainda mais desafiadora. Historicamente, a humanidade tem tido essa arrogância tecnocrática de buscar controlar os eventos naturais, assim como tem sido utilitarista na sua relação com os recursos naturais. Eventos como inundações podem, tecnicamente, até ser controlados em alguns casos, mas a um custo energético e financeiro muito grande. Por isso, o convívio com os processos naturais deve ser uma meta para que possamos restabelecer condições mais seguras e de resiliência. Assim, para sairmos da cultura do controle para a cultura do convívio, temos muito que repensar e refazer, né? Eu trago aqui, muito resumidamente, algumas iniciativas chaves importantes, pela questão de tempo, né? Por exemplo, como necessitamos imediatamente de reflorestamento e recuperação de rios, revertendo uma destruição realizada e que ainda continua em curso. Temos que melhorar as práticas de uso do solo e das águas, apoiados em bases ecológicas. Temos que aprimorar a governança em seus vários aspectos, né, apoiando-se em ciência, se contrapondo ao negacionismo hoje em voga, infelizmente. A forma de urbanização, de fazer a cidade, deve ser profundamente alterada, com ênfase nos processos circulares da economia, assim como nos materiais e das águas. Os padrões atuais de produção e consumo devem ser colocados em xeque. E, por fim, as desigualdades sociais a que eu mencionei devem ser combatidas como prioridade também, em busca de justiça socioambiental. E também para a viabilidade de quaisquer soluções para problemas decorrentes de inundações. O meu tempo está esgotado, eu agradeço e fico à disposição posteriormente.
Many thanks for the presentation. Just want to highlight or let's say emphasize and share my appreciation for highlighting the social environmental justice elements of your presentation. I think that's becoming an increasingly important part of the discussion. I think it's also a moment to share to the participants that, well, acknowledge that we have an all-male panel. That was not the intention of the session, and we actually had more diversity on the panel in terms of gender, but because of a last-minute prioritization, we are on an all-male panel. So I feel the need as moderator to acknowledge that and apologize to some degree, but I think it's a moment to also appreciate those statements in your presentation, Lafayette. So moving along, and I do not think we have time for...
Andrew, yep. I'm just, do you have my presentation handy? My PowerPoint crashed. I'm going to open it very quickly. If you have it, you can launch it. Otherwise, I think, oh, actually I got it. No worries.
You got it? Okay.
Yep.
Okay, so...
I'm going to share my screen.
Great. Over to you, Marco.
Okay, let me know. Can you see my screen, the presentation?
We could see it.
Okay,
yes.
Thanks. So I will take, and I'm going to turn on my camera as promised. I apologize. I just want to take 1 second to do this. Here we go. So you guys can see me as well, and I apologize. I'm good? Can you still see it, right?
Yes, good to go. We could see it and we can hear you.
I'll take no more than 10 minutes. So my job here is to talk about the floods in real estate. I appreciate, thank you to Obassi and Lafayette, and I really appreciate also hearing some Portuguese because I speak Portuguese, and it was very nice to hear the presentation in Portuguese for once. I'm going to talk about floods in real estate. I'm affiliated with Colombia and Nasakis. And also I run a small consulting company called Climate Impact LLC that we deal also with the things. What I'm going to focus on is a lot of the physical attribution, sea level rise. What do we know now? This is part of my bread and butter, what I do every day. But then I'm going to also talk to you about some applications. This is what you're seeing here is basically tide gauge, sea level rise anomalies from measurements from buoys. And you see all over the world where you see arrows going up. Of course, the sea level, the local sea level is going up. One thing that I want to point out is, of course, the distribution of these arrows. Not all the arrows are the same, the size, which implies the sea level rise. Some places it goes down. We can talk about it. Very few of them. It's not because the ocean is now warming up or expanding. It's mostly because the land is also rising. But also, interestingly, you see that, of course, again, there is a distribution. And if you look at this map, which was produced a couple of years ago, and it's being produced of a sea level rise of 22 years anomaly from satellite, the uneven distribution of sea level rise at global scale is clearly visible, and it's driven by several factors: thermal expansion, contribution of ice sheets, currents, and so on. Gravitational pull. One thing that I really care about this group to take home as a message is that the ocean is not a bathtub, and the sea level is rising differently in different places. So one place might not have the same priority if we're talking about 5, 10, 20 years than another place. because the sea level is changing, rising in different ways. So this is something very important to account, especially when you start talking about vulnerability, social cost of climate change, and so on. Sea level rise is also not only increasing, but also accelerating. If you look here at the bottom, I don't know if you can see my cursor here, at the bottom left, if you look at the curve, that would basically, if you remove the quadratic expression, so the acceleration, you're neglecting 0.084 millimeter per year square. Now, this seems nothing compared to the 3 millimeters per year increase on a linear trend, but if you actually start piling that up, by the end of the century, it will give you as much sea level rise as the linear expression. So we're actually missing, if the acceleration continues at this pace, it actually creating twice as much sea level rise as compared to having just a linear approximation. And where this acceleration comes from, it comes from Greenland. Greenland is currently contributing roughly 20% of sea level rise. Thermal expansion, which is basically we warm the ocean expands like the air in a hot balloon, and so the sea level is going up. But Greenland and glaciers are really the largest contributions. Antarctica is waking up, and what we expect in the future, as you see on the right, for the business as usual, in terms of CO2 emissions, we expect Greenland to become the major contributor together with Antarctica. And so the ice sheets will be basically the ruler. Glaciers will go down because there will be no more glaciers left. And again, I'm showing the relative contribution. It doesn't mean that the sea level rise is slowing down. It means also that only the Greenland and Antarctica will be the dominant players. And what do we expect? What can we expect? I mean, what we can expect is, of course, based on what we can learn from the history book of the Earth and from the paleoclimate work of colleagues, even Lamont, the current director of Lamont, Mo Raimo, she co-authored this paper. If you look on the left bar, this is basically the present level of sea level rise. The green shows the CO2 levels, and the thermometer on the top, your average temperature above pre-industrial levels. You see that where we are now is roughly similar to where we were about 125,000, 400,000, and 3 million years ago in terms of CO2 level and temperatures, but the ocean, the sea was much higher then. And we think it's because Antarctica was basically contributing heavily to sea level rise, but then Greenland was following Antarctica because of the changes in ocean circulation. So technically speaking, what we're seeing now in Greenland is still like a small reaction of the polar of the northern hemisphere, and we're still waiting for Antarctica to wake up, which is actually happening as we speak in these years. And this might affect the ocean circulation and then accelerate more Greenland. The bottom line news is that whatever we're seeing here is basically today is very likely underestimating what the acceleration will happen and what we expect to have by the end of the century or in the next years. As Obassi was clearly, and others of course pointed out, the perfect recipe, it's not just about sea level rise. I mean, you can think about 3 millimeters a year. In 100 years, it's a great increment, but if you start putting everything together, coastal erosion, extreme rains, high tides, sea level rise, hurricanes, then you have the perfect recipe for disasters. And also you have the perfect recipe to understand where is the next extreme event going to occur. And this requires so much knowledge to be able to anticipate this, which is nowadays practically impossible. Why is it important? I mean, I know that, Obassi and Lafayette, they've been also showing a lot of interesting slides at a global scale. We have to remember that a lot of the shore adjacent countries are basically, the GDP, half of almost of the GDP is produced along coastlines, basically. 30% of the employment comes there. So it is really a huge asset that is becoming more and more vulnerable, beside, of course, the human aspect, which is extremely important. This is a slide from Climate Central looking about the potential risks of cities within the FEMA's 100-year coastal floodplain. This is very conservative. And of course, you see that there is a lot of cities that were very well known. This is basically in the United States. New York is on top, and this is for today. In the future, things shift a little bit, of course, with Florida and Texas taking the lead on this. beside the direct impact, and I know, and again, the social cost, I just want to reiterate this, the social cost of climate change, the human aspect is fundamental, but we do need to understand the financial and economic mechanisms, because these are the mechanisms through which also a lot of socially vulnerable classes are somehow handled or mishandled from economic perspective. If you're interested, there is a beautiful article that came out a few weeks ago in the New York Times, which is showing how redlining, which has basically occurred at the beginning of the century to discriminate some areas where Blacks and Hispanics were basically living and favor some development to help white people to grow, how that actually is impacting today the heat zones in some cities because of the lack of development. And so the financial, economic, and policy have a huge reverberation to social cost. And one thing that I want to show you is that there's this work by 427, is now working with Moody's. They quantify the potential impacts of climate change on REITs, the real estate trust and basically funds. And they found, if you look at the bottom bullet point, that 37 of the Japanese REITs, they had the entire portfolio exposed to risk for typhoon, and it was for about $250 billion. What my point here is basically, we don't have to wait 20 years, 5 years, 10 years, because of the potential financial reverberations of the extreme events and the potential flood increase they were assisting because of the combination of the factors. I wanted to basically show you some of the cases, practical aspects, because I also, hopefully this will engage or will trigger some discussion and conversation. One of the things that I personally did, I worked on this, was one question I was trying to address in the Hurricane Florence in 2018 was how much the exposure of these properties was due to the urbanization and rather than to the storm itself. So if you look at the inside of this graph, which I will explain in a second, this is showing that the bull's eye of Hurricane Florence overlapped with the distribution of properties over the northern and southern Carolinas. Of course, Florence was very interesting, so to say, because besides bringing storm surge, there was also a lot of rain that released a lot of water internally and created damage where it was not generally expected because of the storm surge. But what you see here with the blue area, for example, is the value in 2018 billions of dollars of the properties that were exposed to the flood caused by Hurricane Florence as the properties were built. And so from the database that I have, I was able to map the distribution of every year of the properties and match them with ones were flooded, basically, or exposed to flood. And this tells you the value. And it actually shows that because of the new increase of properties that were built starting after World War II, there was a huge, of course, acceleration of exposure. One interesting aspect that, of course, I don't have time to show in detail here, but there is a paper published, which I'm happy to share, is that interestingly, between 2010 and 2018, so 8 years before the hurricane arrived, the number of buildings, the properties built was strongly reduced because of the 2008 house crisis, but most of the houses were built nearby water bodies. And so even if you had less properties built, that increased the risk even furthermore because all the houses were built nearby water bodies, and that basically flooded the houses. A second aspect, a second thing that I wanted to show is something that we've been developing to support eventually parametric insurance. The IRI is partially involved with Beth Tellman here. I've been working with people in Italy also. We're looking at passive microwave to extrapolate basically daily 40-year probability distributions of flooding. And I know this image might not tell you too much, Obassi or others, but basically what you see here is what we can try to extrapolate on a daily basis, so we are not limited by clouds, and we can go back to 40 years to build a sort of probability distribution of flood for all the areas in the world. And of course, now we've been looking at Niger because I knew the Obassi was there, and I talked to him about maybe just sparkling, putting this light to sparkle a conversation. But this is something that's very unique and very few groups are doing it, and it really allows to merge this for a probability distribution long term to understand better flooding, which ultimately can be used in models and of course for the flash flood aspect. The last thing that I also wanted to share with you is that, and again, the acronym is very popular, but I couldn't come up with something better. So whoever has help, and I've been working with Caroline Hillquist, and Andrew has been, peripherically helping to develop this Columbia real estate model, which deals with flood. So what you see here, basically the model now, and I've analyzed, I'm writing a short fact sheet document. It looks at the social vulnerability data, the social vulnerability index that and has been put together by NASA and CDC and others. And I think, I don't know, Andrew, I think you're involved with the work with Caroline. And in the shape files and grids. So then we take sea level rise scenarios, FEMA, NOAA, 1 foot, 3 feet, 6 feet, and so on. We merge it with the real estate data, which contains property transactions, name of the borrower, lending institution, everything. We had to sign a lot of NDAs to get this data. We mix it also with the water and elevation data sets. So this is all consistent in database. And then what we can do, we're developing basically a model that allows to understand how price can change based on environmental factors or sea level rise. We can analyze the prices in different mortgages in different flood zone areas. We can actually look at the exposure of socially vulnerable communities through the SVI, through the Social Vulnerability Index data set. We can do some short-term projections. We can try to estimate new flood zone implementation. And ultimately, we can add more data. As long as you have a CSV data set, or if you have a shapefile or a GeoTIFF of any data that concern, let's say, your distribution of properties or your income for people or anything else, we can embed it there and make it work. And this has been done in collaboration with the Columbia Business School, and it has been internally funded by Columbia. This is something I wanted to share because it's very an early stage, and at this point, we could definitely, I'm happy to share it in the future with anyone who's interested in this regard. And that's all I have to say. My email is at the bottom right. I tried to keep it for 10 minutes. I think I was 11. I'm sorry, Andrew.
Thank you.
That's all I have to say.
Thank you, Marco. Thank you for sharing that. I'm sure we'll have questions for you. But looking at the clock here, let's move along. Let me just check this out here. Yeah, if we move on to Jose Luis Zêzere to share your presentation, and it looks like we'll have a few moments at the end for questions. So we do have a couple of questions coming through. Thank you to the people who have been asking. But yeah, now's the opportunity to get your questions in the queue, and then we'll make our way through them at the end of the presentation. So over to you, Jose Luis Zêzere.
Yeah. Okay. Okay, thank you very much, Andrew. Yes, I hope you are already looking on my screen. Yes?
Yes,
okay.
It looks good.
Okay, so first of all, I want to congratulate the organizers of this very nice and very interesting meeting. I don't know if you want me to speak in Portuguese or in English. It depends on you. Maybe in English, Andrew.
I don't think I'm the best person to answer that. I don't speak Portuguese, but I'll leave it.
Okay, no problem. So the idea I will go to share with you a recent work we have just finished before the pandemics, where we present and we propose a flood risk index for municipal land use planning in Portugal. Okay, this was the name of the project, 4 lands, hydrogeomorphological risks in Portugal, driving forces and applications for land use planning. In fact, the project's finished last year. And within the project, we work with floods, river floods and flash floods, but also landslides. And the idea, the general idea of the projects is more or less like this. Okay, we found, and we look over disaster risk, for floods and for landslides. We need the intersections of different drivers. Some of them are typical related with processes, which are covered by the hazard concept, the weather and climate events, but also the physical constraints of the landscape, which constrains both landslides and floods. But disaster risk is also related with territorial and societal vulnerability, as well as with land use changes and evolution on exposure. So our idea is, working all of this information together, we aim to define risk profiles for the Portuguese municipalities, both for landslides and floods. I will show you today only for floods. And the idea also is looking on the adaptation and mitigation at municipal level. We think that the adaptation strategies should be tailored depending on the risk profile of municipalities, because as I want to show you, in our opinion, they are different. Okay, so conceptually, we follow this INFORM, this index for risk management. We didn't apply this kind of thing, but anyway, conceptually, it is a simple, quite simple approach. And our approach, even not exactly the same of INFORM, is a little bit similar with this, which means we found the flood risk, the flood disaster risk in the intersection between the hazard. We take into account rainfall triggering for flooding, but also the flood predisposing based on territorial information. Then also the exposure, and we look the people, we work with the density, the people density, but also the assets and the roads, and then the social vulnerability, and we take all of these, we took all of this information, we cross it and we multiply it to obtain the flood risk index for each municipality. Okay, here is the data we use, the variables we consider: the flood susceptibility, the weather and climate events index, and this for hazard, of course. Then for the exposure, we use the population density, the average road density per municipality, and also the average degree of impervious. And finally, for the vulnerability, we use a previous work on the social vulnerability in Portugal, assessed for the year 2017. Okay, we also, these pictures show you the flood disaster cases in Portugal on the left, and the number of fatalities in displaced people caused by floods per municipality in Portugal on the right. And here you can find, we plot information for a long period, 150 years, and this information we get it from an extensive exploration of information coming from newspapers. Here is in this picture show you the stream flood susceptibility in panel A, the main flood prone areas in panel B, and finally the flood susceptibility already normalized from 0 to 1 per municipality on the left side. These panels in this picture show you the circulation, general circulation weather types that generate mostly rainfall events, which are able to generate peak flows in A, B, C. I have not enough time to go into details in these pictures, but in D, the panel D, we represent an extreme precipitation susceptibility index for the whole country, and at the end, the panel E summarize the complete information coming from circulation weather types and extreme precipitation index. And these panels are related with the exposure, the population density on the left, the road density in the middle, and the average degree of impervious on the left. Okay. Then these are the panels showing the social vulnerability, which were assessed by some colleagues, led by Tavares in 2018. The data refers to 2017. And in fact, they work with two different components of social vulnerability. They separate the criticality, which is in fact those information related more with people, with persons, with families, etc., and also the support capability, which much more related with the institutional support. Here you can see the biggest variables or groups of variables associated with both components. For criticality, the upper table, the existence of risk groups, the economic conditions, but also the presence of disadvantaged population, the level of income, the employment, the dependent population, and then for the variables that's mostly associated with support capability, for instance, the civil protection response, the economic and environmental dynamic, and also the logistics and services capacity. And finally, here we have the three main drivers of risk: the hazard, already addressed on the left, the exposure on the middle, and the social vulnerability on the left. All of them already normalized per municipality. We have around 275 municipalities in the whole country, and the data is normalized ranging from 0 to 1. And finally, here is the map we obtained for the country. This municipal flood risk index, and it is important, for instance, when we go into detail into the data, we can see that the same risk index can be explained or associated with different way with hazard, exposure, and vulnerability. This is just an example. Two different municipalities. Amador is a municipality within the Lisbon metropolitan area, whereas Marco de Canaveses is a municipality in the northern part of the country. As you can see, the risk index for floods for both municipalities is the same. It's exactly the same, but the composition of this index is very different for one municipality and the other. In Amadora, is this exposure is the most important driver for the risk index, whereas in the Marco de Canaveses municipality, social vulnerability and also hazard are much more important than exposure. So we also plot on the map these clusters of municipalities showing different risk profiles obtained with different crosses of hazard, exposure, and vulnerability. The idea is like this: the municipalities represented in blue, which means the municipalities associated into the cluster number 5, are those where the flood risk index is mostly resulting from the hazard. Then in gray, namely in the nearby the ocean, but also here near Lisbon, the gray represents the clusters number 2 and number 7, those where the most important driver is exposure, and the pink, the municipalities representing with this pink color are those where the vulnerability is the most important driver. So the idea is, okay, when our stakeholders and decision makers have to make and to take decisions regarding the management of flood risk, they should take this information into account, because the origin of the problems is not the same everywhere. So if they take this information, and when they take this information into account, the possibility to have good options regarding risk managers increase for sure. If you want to have more information on this work, you can find it in this journal. The paper was just published already this year, in the beginning of the year. And thank you so much for your attention.
Thank you. Thank you so much, Jose. And thank you to all of the presenters in this session. It seems that I appreciate the framing of the discussions and the presentations, not only to be clear about the challenges and the constraints, but also present a lens on the opportunities to move forward. And I think that's something that the participants and as well as myself will hold with me throughout the rest of the summit, to think about what those opportunities are, where do we share those opportunities with other organizations, with other people, with other researchers, and how do we align them with this multifaceted kind of approach with the science, policy, and then bringing it down to action. So I would like to, on that note, I would like to move over to the questions. We do have some questions, so thank you everyone for submitting your question, and I encourage more people to do the same. On the note of policy and the idea of integrating all of the research, the cutting edge science into policy, many of the examples, not all, but many of the examples today were national or subnational examples. And we all know that many times floods don't know boundaries. They don't know political boundaries. And there's challenges in understanding not only what's happening upstream, but also how that will propagate downstream, cross borders, different populations, and different economic activity zones, for example. So we do have a question that's for Obassi Ettu around the transboundary governance in flooding in Cameroon and Nigeria. And I'm also interested in your reaction to this, Obassi. Obassi, can you see this question? I'm not sure if this question went to you, otherwise I could read it. I believe you're on mute.
Can you read the question for me?
Yes, so it says often we hear in the east of Nigeria that flooding is often linked with flooding elsewhere in Cameroon. How true may these claims be, and does flooding in Nigeria require a larger regional strategy, is the question here. Over to you.
Okay, thank you, Andrew. It is quite true. Most of the flood activities, the river sources, if you look at them, are not mainly from Nigeria. For instance, the Niger River comes all the way from those Guinea highlands, passing through Niger, Burkina Faso, and entering Nigeria. And on these rivers, the River Benue and this, Nigeria does not have any major dam on those rivers. The dams that are located in these rivers are outside the Nigerian shore, like the Lodga Dam, which comes from Cameroon, and the other ones from the Niger and things like that. And each time they open up this to let water overflow, Nigeria stands at the receiving end. So it became very expedient to start discussing with governments of this country, because they are also facing a challenge. But Nigeria needs information to know when the dam is going to be open or things like that the day beforehand, so that if there is need to evacuate people on this. So there is a diplomatic aspect of it that is happening at the high level, discussion between Nigeria, Cameroon, Nigeria, Niger, Nigeria, Benin Republic, to take care of some of these incidences of flood that come from from the boundaries outside Nigeria.
Thank you. Thank you for the reaction, Obassi. We do have to wrap things up. I think we have, actually, I believe we don't have time for any further questions. We will be going back into plenary. Well, actually, I see here we do have a few minutes left. So I wanted to open it up to the panelists. Do any of the panelists have questions for other panelists or any reactions that you have. I think we have just maybe time for one or two brief reactions from the panelists.
I have a question possibly for Marco.
Yes, go ahead.
Marco, thank you very much. I've already seen what you did is a good work. I want to find out how your model or this thing can help Nigeria, especially with the flood that comes usually outside Nigeria.
Yeah, and the short answer is that the coverage of the passive microwave is global. So you can actually look at even other areas where there's clouds and rains outside Nigeria. So you can actually start having an idea of what's coming in. That's from the satellite. From the model perspective, of course, if you have this information, you can then start having, merge everything into the model. And one thing that you, as a Niger representative, you have access to data from Niger that could be used into that model. And that basically replaces the data that I'm using for United States. So in this regard, you can expand your region much wider. That's not an issue, Obassi.
Okay, I will take you up on that, because if we need to provide some data, we'll need to do that, and we could possibly do some of these mappings or satellites. What do you call them? These your drone monitors to see how we can possibly arrest the flood in Nigeria before the action actually occurs.
Yep.
Great.
I know we're on that time, but if you need a question, I have one. I don't know. I don't want to take them up, but others might have questions.
Lafayette or Jose, do you have any reactions? We actually have 3 more minutes before we're going to have a hard stop in 3 minutes. So any reactions, please go ahead.
I'd like to address a question to Luiz, Zêzere. Okay, can I do it in Portuguese? I'm afraid of stuttering.
Claro.
Ok. Bom, desculpa falar em português para os demais aí, mas, Luiz, é interessante o trabalho que vocês fizeram do índice de risco para o país todo, para Portugal, e alguma coisa similar está sendo feita aqui na nossa cidade, né? Pensando na questão de mitigação, adaptação a mudanças climáticas. Mas eu pergunto, após esse trabalho, em que nível poderá isso aí ser utilizado em termos de políticas públicas? E a questão interessantíssima que esse Boto colocou, que é uma preocupação, às vezes o mesmo índice de risco está sendo, tendo, né, como causador daquele valor diferente, ou é a vulnerabilidade, a exposição, ou enfim, whatever. Então, como nesse caso diferenciam um caso para outro, assim, e se isso aí já está sendo aplicado em alguma política pública, enfim.
Sim.
Se quiser, pode responder em inglês. Ok.
Okay. Yeah. Within this was a national project that were financed by public money from our government. And within our team, there was an institutional group belonging to the Portuguese Special Planning Ministry. Okay, so they work with us. They were within the research team, and the idea, this kind of looking on the scale of our approach. This is maybe really useful for them. They think they intend to use this information to hierarchize the giving of money, for instance, for municipalities to try to solve the problem and to tailor the measures. The point, and this is, in my opinion, the importance of this kind of findings, because if the problem in a cluster of municipalities related where the flood index is high, if the reason of this high level of risk is vulnerability, is social vulnerability, maybe it is not necessary to build a new dam, for instance, to monitor and to regulate the floods, but to invest more, for instance, on education, etc. So this is for them, for the not only for municipalities, but for the region, for the regional governments, and for the national government. This kind of information is, in our opinion, but also in their opinion, very useful. Okay.
All right, great. So I just have notification. This session, the live session, has now ended. So thanks, everybody. There is an option to continue the Q&A if you go to the Zoom on your screen. But now there is the 12 noon session. So we could wrap it up here. Thank you, everybody, for participating. Thank you to the speakers, everybody.